Kublai pi baru ki bape ikan ni ke video yang subhai fi shakan ni ke channel ke TikTok Meghalaya bela permi de ke SCSTE ke kerteng junga kalong I ba pediang hun kongwil but hakan ni ke porpat ngan batai pi shapang ke Gauss theorem or ke Gauss laws in electrostatics. Alright, tingin pet menta kan ni ke statement junga ni ke Gauss law ke ong kumno. Tiga statement junga Gauss law ke ong the surface integral of the electric field produced by any source over any closed surface S enclosing a volume V in vacuum, that is, the total flux over the closed surface S in vacuum is 1 by epsilon naught times the total charge contained inside S. That is, in mathematical expression, we thought phi E ke electric flux, alright, E stands for electric. Phi E is equal to closed surface integral. Now, ini integral badan circle kemudian, ini is surface integral, okay, of E dot ds. So, what is E dot ds? Again, E dot ds is nothing but the formula kebangi like your na previous video, alright, kan the formula of flux E. They according to Gauss theorem part, flux is equal to 1 by epsilon naught times of the charge Q, alright. 1 by epsilon naught into charge Q, alright, which is nothing but Q by epsilon naught. Okay. This charge, alright, inside S may be point charges or even continuous charge distributions. Kapamut ba? It can either be, alright, new charge Q, ula benda discrete, lain ula benda continuous charge distribution, kemarang ni, alright, where we have here ni the charge wire, hani pat ke ula benda ke charge plate. Okay, ila ban use ya kan ni Gauss law, alright, ban phi ni ka, alright, ka flux either jung ini iwi charge, lain ni jung ni continuous charge distribution. Alright, they can ye kadika way kajing pair between the Coulomb's law but the Gauss law. Coulomb's law, if you still remember, Coulomb's law is applicable only with discrete charges. The charges ki berat belong iwe. Alright, gimana na pen use ka Coulomb's law ban find ye ka electric field, alright, of continuous charge. Alright, of continuous charge distribution. Kadba, alright, ya ka Gauss law pat ngila ban use for both cases. Lada de iwe charge ngila ban use, lada de continuous charge distribution, alright, for example, in a wire, in a plane sheet, alright, ngila ban use in all cases. Kata de kajing pair between ka Gauss law but ka Coulomb's law, alright. Note that down, kalong very important mafinte be kata. The next, na antade kani ka Gauss law ka ong ba ini I charge idi bendan hai. It even done inside a surface area, alright, inside a closed surface area. Aka previous video ng labatay fi the difference between an open surface area but a closed surface area. Open surface kini what type of surfaces? Kini ki 2D surfaces, ki rectangles, squares, circle, triangle, right, so on and so forth. Kat baki closed surface area pat kini ki jat object, for example, ki cuboid. Cuboid, sphere, alright, linear, cylinder, and so on and so forth. Okay, they according to Gauss law ko ang ba ini charge, ide been done within this closed surface area. Tementa ini charge plus Q. Hatu done within a closed surface area. Hatu ka done ke surface area hangye kam done re. Teknang bangila ban penon kami gani Gauss law ni construct hi ya kata ka surface area ken. Okay, then nakabintay ni charge ngala ban construct the sphere. Aba surround ni charge ha padeng. Alright? Okay, they kani ka sphere, alright, kani ka bang construct hi, kani ka sphere ni kata ka Gaussian surface. Alright? Gaussian surface kani ka kadai ka surface area ka bangi construct hato kani ka surface area ka dan ningkom kam dan re. Alright, so we can say kani Gaussian surface and kadai ka imaginary surface area, imaginary closed surface area. Alright, don't forget the word, okay, what nam kelat ka contain closed, namar ka penya pair between open and closed surface area. Okay, Gaussian surface and kadai ki closed surface area ki surround, alright, ya charge. Clear? Then now, nakabenta kini continuous charge distribution rule. How to ni wire menta? Alright? Udan inside any surface area. Ungdan re. Again, nakabenta kan niro ngan haban construct hi, ngan haban draw hi ke surface area. So let's say nakabenta ni wire ngan draw da cylinder. Alright? Dia minta filaban ni wire ila adan hapo jang cylinder. Again, this cylinder is a Gaussian surface. Alright? Tingnan its templason to minta what is a Gaussian surface? Gaussian surface ketika takas closed surface area kabangihi construct, alright? Over a charge, alright? Over a charge distribution and over a single charge. Okay. Tiflapan ong yang balay mengidan kaman construct yan nga Gaussian surface. Na marba ka Gauss law ka ong kumno. Ka Gauss law ka ong ba, it is the total electric flux over the closed surface area, alright? Is epsilon naught times the charge, alright? The total charge contained inside S. Okay. Kapamwat ba, kani ka flux, alright? Kabangin ken hani kade ka flux kabami naki charges ki badan hapo jong ka surface. Ladadan ki charge ki badan shabar jong ka surface. Kita can contribute them ka flux. Can contribute. Okay. Te hangnif kembali imentai ni dah dia hapo jong ni sphere dan ni charge plus Q1 shabar dan plus Q2 but plus Q3. Te nakini ki lightly ki charges. Which ones will contribute to the electric flux? The nakini ki lightly charges, which one will contribute to the flux? Datang kita ki charge ki badan hapo jong ka closed surface area. The which one is inside hapo ka surface area? Datang charge plus Q1. So only plus Q1 on contribute siya ka flux kabangin calculate, alright, which is given by phi is equal to integration, close integration over E dot ds equal Q by epsilon naught. Alright? The new charge Q. This charge Q, alright, is equal to only plus Q1. Okay. This charge Q is equal to only Q1 ken. Hangning inam thore yu Q2, inam thore Q3 in mabalay. Kimnante hapo ka surface kidan shabar. This Q is talking only about the charges ki belong enclosed. Alright? Ki belong enclosed. Right? And which charge is enclosed inside the surface area? Only charge Q1. There is no contribution to total electric flux from charges outside S. Ki charge ki badan shabar jong S, kim ju contribute re shaka electric flux, alright? Only the charges inside S, alright? Inside S ki contribute shaka electric flux. Te hakapor bangi ni choose roi ka Gaussian surface ban draw ngim ju draw roi ka Gaussian surface, alright? Hata rukam ba utaw charge udon hani surface. If I have a charge here, alright, say Q4, alright? Kanum long rukum ni. Alright, gimna ban draw kum dia. Shubu ang pa ban siem lang ni Q4 hapo jang ka Gaussian surface. Alright, dengan lek kum no ngan draw ini Q4 dah ni. Alright, ngan draw ka sphere ka ba kin top yu Q4 hapo. Umde bendan halor slah. Alright, umde bendan haka surface. U Q4 ki charges baro ki bangin draw ki di bendan bed hapo jang ka Gaussian surface. The surface chosen to calculate the surface integral is called the Gaussian surface. While selecting a surface, we shall avoid charges on S itself. Ki charges kimdere bandan on the surface itself. Alright? Kidi bandan inside. Timintang inyepet a few important points ki bai day baganika Gauss law. Point number 1, Gauss theorem is independent of the shape and size of the closed Gaussian surface. Kabamot ba, alright, kani ka Gauss law, kalong kamshongkin haka shape yu bangishim. Nangishim ka sphere, nangishim cuboid ne, nangishim the cylinder ne, compare kata. Alright, ilaban shim kanu ka shape ro. Te kata ilaban I na ka formula itself. Formula ka phi E is equal to Q by epsilon naught. Te kani de ka formula kabang yo na kani ka Gauss law baong ba the total flux is equal to 1 by epsilon times the charge Q. Te hangni, do you see any term kaba relate siya ka shape jong ka Gaussian surface? Is there any term? Phi is flux, Q is charge, epsilon naught is permittivity. There is no term kabakaran siya ka surface. There is no term kabakaran siya ka shape. So therefore, ang iong ba ka Gauss theorem, alright? Ka I ka flux kabalong independent, alright? Kalong independent of the shape. Ada day ka cuboid ru, ka flux can pass through bit, ting ba ka cuboid. Lada day ka sphere ru, the flux can pass through bit through the sphere. Lada day ka cylinder ru, the flux will pass through the cylinder. Alright. Point number 2, kaong Gaussian surface chosen should not pass through discrete charges, or in other words, no discrete charge should lie exactly on the Gaussian surface. The kumbang laong mene, habang i-draw ka to Gaussian surface, in habang pit baha ba utu charge umde bandan on the surface, udi bandan hapo jangka surface, okay? Okay, point number 3, in the situation when the surface is so chosen that there are some charges inside and some outside, the electric field E is due to all the charges, both inside and outside the closed surface. However, for electric flux, the term Q represents only the total charges inside the closed surface. Alright? The kumbala omene, but electric flux according to Gauss law, kanya ki charges ki badan hapo ajang surface. For example, hangni inside this sphere, alright, ngadan lightly ki charges, ngadan Q1, Q3, Q2 and Q3. Alright? Shabar par ngadan Q4 and Q5. Alright. Te kumbang na puli shakman babaro ki charges kidan ka hasaw dong jong kidan ka electric field. Kapamot ba u Q4 rudan electric field, Q5 rudan electric field, Q1 rudan electric field, Q2 rudan electric field, Q3 rudan electric field. Kidan ka electric field lagi jang. Alright. Te Minta, suppose if Q4 and Q5, alright, ki positive charges. And ki electric field due to positive charge, ki point come no towards ne away, she point away. Alright. So uni Q4, if I say it is a positive charge, then electric field can point away. Alright, can point away. Alright. Can point sha. The same thing with Q5 also, if it is a positive charge, then it'll point away, alright, in all direction. Now, the baro ki charges ki dana ki jang electric field jong adi, alright. Tila na consider ki baro ki positive charge kumangitip, but electric field jong baro can point away. Fine. The hang fi e uni u charge plus Q4 plus Q5 fi inam ki electric field. Ki enter inside the surface? They do enter. They pass through, alright, this electric field line, it passes through the surface area. This electric field line also passes through the surface area. Alright. They can charge Q1 also, VM electric lines, ki pass through the surface. Q3 also, they pass through the surface. Q2 also, they pass through the surface. The fi in am. But electric field pass through the surface area. Kamdiri tang ka electric field jong Q1, Q3, but Q2. Henry ka electric field jong Q4 and Q5 also pass through this surface area. Nakatakadang yung baka electric field, alright, kanday due to both ki charges ki badan siya po can contribute, ki badan siya baro can contribute siya ka electric field only. Right? Can contribute to electric field only. Kabamut, hakani ka formula, alright, kumbangila tipmane, ba phi, in other words, we can also write is equal to surface integral of E dot ds, alright, equal Q divided by epsilon naught. Kabamut hangni, kani ka electric field yishim ka electric field jong baro, due to Q4, due to Q5, due to Q1, Q2, and Q3. Alright? Whereas, however, alright, ki charges par ngin shim tang jong A, charge Q, can they charge U, can they take tang charge Q1, Q2, but Q3 ki badan hapo jong ka sphere. Okay? They what kulmarjumot e kata, alright? Ki electric field kuma oifi, electric field naman baro ti kidan electric field. Electric field lines can pass in all directions, separate directions. Alright, so electric field jong Q4 can pass through the surface. Jom Q5 ru can pass through the surface. Alright? The Q1, Q2, Q3 ki badan hapok lupa they can pass again through the surface. Alright? So therefore E is due to all charges. Hapok ni shabaru ampere. Alright? Kat ba u Q pada. U Q te u debitang ki charges ki badan hapok jongka surface. Alright? Hapok jongka closed surface. Okay? So I hope you are clear about this point. Tingin nipit sa next point. Te ka point ka basal ko ong Gauss theorem is used most commonly for symmetric charge configurations. Okay. Ayu kata symmetric charge configuration. Shumudor yeladi, alright? Mudor pi yang hapdeng, alright? Jongkawe ka kamera ka bapelun. Alright. Te dafi pet menta dafi pai sao dong. Finsgo dan jia pere etrai hata kamera. Nefini kanong kumju hine. Kanong kumju. Lamar ba katu ke kamera bapelun, alright, the fi yang be happening at the center. You'll find back a distance jong fi, alright, baca ko kenro kalong be kajut, fi picture drong kalong kajut, fi picture po ru kalong kajut. Day, dikatakan di symmetry. Kabamut ba lada fi done, alright, ka charge distribution kabalong spherical. Okay, kabalong spherical mutta on the surface kidan ke charges sao dong kumtu, alright, on the sphere tidak da fi yang pedeng fin the page drong ru fin idan charge support ru dan charge left ru dan charge right ru dan charge sao dong kidan ke charges but ke distance jong ke charges kalong kumju, alright, dikatakan kedeka surface, alright, symmetric charge distribution. Okay. Right? Tingin pet menta ke symmetry mo fi in terms of a sphere ke symmetry ke de balada fi bu hapdeng. Alright? De habaro so dong shu de gidan ki charges kumne. Alright? The ini charges baro gidan equal distance from the center O, which is the distance R. Kabamot ba shubu da fishim ngani ka sphere fi pia hang ni marshiteng, alright, fin sa fain ki charges chane ki long kumjo kum ki charges chatai da fi pia da kumne fin pe ki charges cha drong ki long kumjo kum ki charges shapo, alright. Te in terms of a cylinder but ka symmetry kan kum no kadan artli ki symmetry ki bangi la ban pet, alright, in terms of cylinder ka we ki symmetry ka la ban dei la dang pia na ni na pedeng. Dang pia na ni na pedeng, alright, ni na pet cha drong ba shapo kadan ka symmetry kilong kumju, alright. Te dangi pet pedes another symmetry kade lingbao new axis ba pass through in the center jong in the cylinder, alright. Dangi pet ka ba shatai ba shane ka symmetry kalong kumju, alright, ka shape kalong kumju kamdan jinga pair. Fine. In terms of a plane sheet pada again ni dan kumju hi ada ngapia ni na pedeng ka left side ba ka right side ka shape kalong kumju. Dan ni dengan pihak kumni horizontally ru shadrong ba shapo, alright, ka shape ka longkum jo. Te ki symmetry, alright, ki dan hadut lai jat ki bangi jupenan kamna bentaka Gauss law. So the three types of symmetry where Gauss law is most useful are spherical symmetry. The spherical come from the one that contains sphere, alright, but use ka sphere haka bangi penan ladangi penan kami ki point charges. Tinggi lihat kumno ki point charges ngishibu at the center of the sphere. Okay. Te kabaa kadika cylindrical symmetry, but ka cylindrical symmetry kani cylindrical ka one that contains cylinder, but ika cylinder ngijipenan kam ladangi fine, alright, nakabenta infinite line charge. Kabamut ka linear charge distribution. But kabalai ketika planar symmetry. Ketika planar symmetry pada ni she use nakabenta infinite plane sheet of charge. Alright. Teka bamut ba idan ka plane sheet, alright. Kabadan she won't teliki charges. Tekini kita ki lightly ki symmetry ki bangi jiben pendam kam bon sin, alright. Hapor bangi use ka Gauss law. It's kan pilas ngotho ikat ka jing batai jung Gauss law, but ki different rules ki banki ni haban follow ka por bangi peran kami ka Gauss law. Ti sa example ye phi ka wika video ka bangan batai shapan ka electric field due to an infinitely long conductor. Kobleshibut.